Let us solve the next problem. So let us find the total derivative for this, right? So what is the formula here? Here u is a function of x, y, z. So u is a function of x, y, z, and x, y, z are the functions of t. So we can calculate the total derivative du by dt. So using the formula. So what is that? So du by dt. So that is equal to. So now let us calculate the derivatives here. So let us find the derivative here. So let us calculate dou u by dou x. So remember here y and z are constant. So here, so y is constant. So take that outside. So let me write this. So dou by dou x of xy plus dou by dou x of yz plus dou by dou x of zx. Now we have to mark the constant terms here. Since we are differentiating with respect to x, y and z are constant here. So now we can take the constant term outside and differentiate the remaining. So differentiation of x with respect to x is 1 plus the differentiation of constant term is 0 plus z. I can take z outside. The differentiation of x with respect to x is 1. So it is y plus z. Right. So we can calculate. So dou u by dou y. So here x and z are constant. So here x is constant. Take it outside. The differentiation of y with respect to y is 1 plus here z is constant, take that outside. The differentiation of y with respect to y is 1 plus here z and x both are constant. The differentiation of zx with respect to y is 0. So the answer is x plus z. And we can calculate dou u by dou z. So here x and y are constant. So the differentiation of x and y with respect to z is 0. Since they are constant, here y is constant, take that outside. The differentiation of z with respect to z is 1 plus the differentiation of x is constant here. Take that outside. The differentiation of z with respect to z is 1. So we have it is x plus y. Now let us calculate the derivatives here. It is dx by dt. So to find the derivative of this, we have to apply the product rule here, right? So first function, the differentiation of cos t is minus sin t plus second function, the differentiation of t is 1. So it is minus t into sin t plus cos t. Right? So let us calculate dy by dt. So here also we have to apply the product rule here since the both of the functions of t. So first function into differentiation of sin t is cos t plus second function into differentiation of t is 1. So it is t cos t plus sin t. And the differentiation of z with respect to t. So here z equals to t, so it is 1. So now let us substitute these values in the given formula. So let us substitute these values in the total derivative formula. So we have, now let us substitute the values of x, y and z. Now let us multiply these terms. We get, so let us multiply these two terms now. So now let us consider this term now. So now we have t sin t cos t and plus t sin t cos t. So it is 2 times t. So sin t into cos t. Later we have minus t square sin square t and here minus t square sin t. So we can take minus t square sin square t and here plus t square cos square t, right? So let me take so minus t square common. So it is sin square t minus cos t. So if we take minus t square common, so it is sin square t and here it is sin t and here we have minus cos square t since we are taking minus t square common and here it is minus cos t. So now let us take, now let us write the remaining terms. So here we have t cos t and t sin t. Here t cos t, t sin t. So we can write it as 2 times t into cos t plus sin t. So this is the total derivative.